Q4OS was already lightweight, but this version is pure power. Thanks to its new concurrency management, it flies and destroys all. It has shattered records in almost every test. The boot time, it is officially the fastest I have ever recorded among all distros. It brings a native installer for NVIDIA, a great hit. But the main question is, did it achieve the best graphics in channel history? Stay here to see it all. We entered the website and it shows us all its features, from stability and dual installation to speediness. There are several download types. I will select KDE Plasma. Another video already showed. It is more efficient and visually better. We boot up the image and wait for the operating system to start. You can use any image burner. You can even use Ventoy for this. Upon entering, it asks for the language. We select English, it finishes configuring and shows the welcome screen. NVIDIA card found. We run the installer. It asks for the language. Select your choice, then enter your location and the keyboard layout being used. There are several installation types: desktop, basic, live, and pure. For evaluation purposes, we will select basic. You choose. It asks us to select the disk and the installation method, like erasing the disk. Then we enter name, username, and password. We activate automatic login without asking for a password and press next. Then we press the install option so it can finally start. Version 6.7 promises a lot of efficiency. It is still a Debian-based distro and aims to be lightweight, user-friendly, and stable. We press Restart Now. The system boots for the very first time. The boot speed is extremely fast. We wait for the system to load. We start the review, and Q4OS indicates that NVIDIA drivers are available. We press Yes, then click Next, and finally hit Install. The interesting thing is that there is a driver installer that tests the hardware with available drivers in a very friendly way. We restart the system. The NVIDIA module will load. We wait for it to reboot, enter the desktop, and open terminal for the tests. We execute NVIDIA SME to verify that drivers are correctly installed. Then we install the FastFetch and Sysbench software packages. Then we run FastFetch. The kernel has an average version. Idle memory is average and disk megabytes used by packages are quite low. Now we execute commands to review the information, taking into account the distribution version, the kernel, and the memory usage. Next, we review the space consumed on the disk. Now we verified the boot time minus the firmware time, which is actually the fastest. Now we run Sysbench to evaluate the system. We test the CPU using a single thread. The result obtained in this test is excellent. We run the test with the CPU, but using 5 threads to check the concurrency management. A very good result is obtained here. We test the threads directly with Sysbench to evaluate how the system handles concurrency. The final result was truly excellent. Now we evaluate the mutexes to see the efficiency of lock handling using 5 threads. The result in comparison was very good. We will evaluate the memory reading to check how the operating system handles it. The result of the reading test was excellent. Now we will test the memory writing to evaluate the speed at which data is written. The result obtained was completely decent. Next, we prepared the necessary files to test input and output. The sequential write speed of the disk was completely average. We run the test indicating that the mode will be random write and read. The random read and write result was completely excellent. Now we install Firefox because we selected the basic installation option. Then we will be able to measure the browser memory use. Now we run the top command. We run Firefox to analyze the memory consumption per browser tab without loading any extensions. We open a second tab loading a video. With this, we want to measure the memory consumption when opening several windows on average. Now we open a third and a fourth tab. Then we calculate the average memory consumed per tab. The final result was just average. Since we verified NVIDIA's ME, we proceed to install GLMark2 and Hashcat packages. We run GLMark2 and it uses the default card to render, which is the Intel card. Build measures the capacity of the driver and GPU. Effect 2D evaluates accelerated 2D rendering. Desktop simulates a real desktop environment to measure compositor performance. Refract simulates light refraction through transparent surfaces. The score obtained by the Intel card in the test was very good. Using environment variables, offload, and vendor, we run GLMark2 to render with NVIDIA. With the jellyfish test, many moving semi-transparent objects are rendered shadow. Evaluates dynamic shadow projection features. Loop evaluates the efficiency of loops inside shaders under load. The NVIDIA card obtained the best score recorded up to now. We execute the Hashcat command -I to see the recognized devices, ensuring that the GPU must appear as device ID 1. If it is not like that, we must install NVIDIA OpenClickD and OClickD libopenclick1 packages, which will serve to use CUDA properly. We test the Hashcat command -I again. In this case, the GPU must appear as ID1. We run Hashcat, which tests CUDA using hashes. MD5 is an old and fast method, while SHA-1 provides much more security to users. SHA-256 provides cryptographic resistance. SHA-512 uses extensive hashes and requires more resources. On average, it was excellent. The evaluation of Q4OS has finished. Now we will turn off the system before sharing the conclusion derived from the analysis. In conclusion, the new version of Q4OS has significantly improved its performance, even though it was tested with heavy plasma. It broke several records, such as the processor multi-threaded performance, the boot time, and most importantly, NVIDIA results. This is all for this video. If you liked it, subscribe, leave a like, and turn on notifications. See you in the next video.